Quick question, Professor. Did you receive an updated list on the vaccination?
They didn't do anything. Okay, now, you think you're done, right? If you think you're already done, then
Yeah, so I was just kind of curious if you got an updated list of people that are vaccinated so we can join the lab.
now the thing is, okay, normally on Sunday, we report the name of the student. That means the schedule for the guy. You're doing the lab the following week. If you see your name, that means you're ready to do it. And the other thing, you know you already think you're already clear. And didn't see your name. Okay? Then you just text to me. I will be telling you what next step to do. Otherwise, waiting for, I don't think they can do a good thing. I can send you to the mid-city. The manager up there, they can be verified right away.
Okay, that sounds good. Thanks for the
And
clarification.
the thing is, you know, they keep sending me the update every week, but I looking into that. I didn't see any different. Not the same. So that's why I already have some students. They let me know. So that's why I send an email for the mid-city asking to verify for me. The thing is the student need to get into the lab room. So that's why we can have a little more student. And basically, you cannot see any listing of the student to be clear or not clear, okay, in the Zoom. We're not allowed. That's what they call personal information. That's okay to me. Okay, anything else? Otherwise, I have to share.
Mr. Pham?
Yeah, anything.
Will we see the lab schedule for next week today?
No, on Sunday.
Oh, okay, thank you.
I will be uploaded into the let's see, handout. You just go into the handout. Then we will see the schedule for the next week lab. Okay?
Yes, thank you.
Yeah, and make sure you let the lab instructor know you're done for DC. Okay? Then they will be assigned for you either AC1 or semiconductor, that electronic. I think you already learned last semester for AC circuitry. And AC module, you get only 2 board, AC1 and AC2. And in electronic, you will be get more. Okay, as fast as you can get the lab done, and you already go to electronic, AC, and digital, then you can get a certificate. Now the city, they're working Monday to Thursday, not Friday. That means in the office, we get the employee working now, so that's why we're able to get a certificate. Okay. Okay. We're talking about diode. Okay, we not go over again. For physical, that means the
Can't hear you, Mr. Pham.
yes, sir. Go ahead. Is it low?
The internet, the sound was disabled for some reason. Must be the internet. Excuse me.
Fine.
Didn't you hear me?
Yeah, very clear.
Yeah,
Okay.
Yeah, we can hear you.
Okay, anyway. Diode, basically, we already go through that last time. That's what we get a P and Johnson. That means one will be contain the whole positive, the one contain electron. Okay. And this is the symbol for the diode. So when electron able to moving, okay, to the P side, that means you get the current level. Okay. So what is the basic definition for the diode? They say diode, a rectification. Device. Now, what that means? How much you understand when they say diode is a rectification device? So now tell me.
Flow
It allows,
only one way.
yeah, allows
Yeah.
current in one direction.
No, that's not quite. That is the way diode working. That means they allow only one way for the current flow. However, in general, they say diode is rectification device. What that means?
Changes an AC current to a DC.
Exactly.
Yeah, correct.
Exactly. That means convert AC to DC. That for rectification. Otherwise, they're talking about rectification, you don't know what is it. That's just a device. They're able to convert AC to DC. Okay, the thing is, if you question or confused, just bring it up. If I can answer it, I can let you know.
Mr. Pham, can I ask a quick question?
Go ahead.
Obviously, power comes from the power line into the wall of your house, and most of the devices in the house, they operate off of DC. So the diode is, you're saying that it's needed to change that AC into the DC?
Exactly.
Okay,
Or not the equipment. Inside they're using DC, not AC. Engineer cannot design with the AC. So that's why they must be converted AC to DC. And the diode, that's the one can do it. Okay, now, when you say this symbol, then you recognize this is a diode. Basically, this side A, this side C, anode and the cathode. Okay, and the voltage across the diode. That's what they call a VD. VD means diode voltage. And equal basic definition, the difference between VA minus VC. Okay. Now, this just for your knowledge, but really it not happen. Ideal diode. Then VD equals 0 volt. Okay. That means VD equals VA minus VC equals 0 for ideal. Okay. And the diode can be either they can be on or they can be off. Okay. On, that means they allow the current flowing from A to C. Okay. Off means they open, no current. Flowing. And now if you're looking into that, it says revert bias, same thing for the off. Forward bias, they will be on. Either way, you say off, that means they revert bias, or on, forward bias. And you is easy to recognize. When they off, they look like the switch they open. Okay. When they open, that means no current can be flowing from A to C. And when they be on, forward bias, like the switch closed, current able to flowing from A to C. Okay, but only thing you want, make sure you memorize on this here is ideal diode VD equal 0. Okay, now we go to what they call a second approximation. That's what we're working on. Okay. For the second approximation, and depending on what material they make the diode. Okay. So if I say for silicon diode, then the VD 0.7 volt. That means the voltage across the diode 0.7. Okay. However, for germanium, and VD equal 0.3 volt. That's a different potential for different type with the silicon or germanium. However, most of the diode we're using or working will be 0.7 volt by using the silicon. Okay. Now, same thing. That means that will be A, and that will be C, and the voltage here, VD. Okay. So this is the diode open. Up. So that's why no current flowing. I cannot flow it. And this will be on. Okay, or forward bias. Then you can see they can get the, like the switch they close, current can be flowing. Okay. And diode will be substituted by the battery, 0.7 volt. Now, when you're working with the diode, if you don't know they be on or they be off, okay, then you cannot solve any problem. First of all, must be know is it the diode on, reverse bias, and a forward bias. Okay, that means they off or they on before we can do anything. Okay, so now I try to explain a little more for you. Why 0.7 volt for silicon? Okay, so that will be positive. That will be negative. Electron. Okay, electron can be moving. Okay, from P N side to P side. And this what they call a barrier. Okay, for silicon, VD 0.7 volt. My question is, why 0.7 volt? Why they asking for 0.7 volt for VD?
Because it's silicon.
Why?
Because that's the voltage necessary to get the negatives to move to the positive.
Exactly. That means at least you get 0.7 volt. That's enough power for the negative electron move through the p side. That's why you get a current. Okay, like exactly, when you say you apply the voltage less than 0.7 volt, that's not enough the power for the electron able to move from N to the P side. So that's why they still not any current. Okay, that's for the silicon. Germanium, they only require 0.3 volt. So now you understand why 0.7. Okay, the thing is, if not get up to 0.7 volt, electron cannot move it and no current. Okay, so I need to see what I. Okay, now you're telling me if I given this circuit here, okay, 4 volt, 1 volt. Okay, only thing I want to know, on, off.
On.
Same thing. Okay, the first thing on off,
The first one is on
how do we know?
because the anode is more positive than the cathode.
You need to do calculation. Oh man, what the? Okay, you need to do a calculate the VD,
It was a VA minus VC.
right?
Uh,
VA minus VC, 4 volt minus 1, you get 3. Greater than 0.7 volt, so you say on. Next one. On off.
on,
On.
Okay, VA round 0, minus to minus 2. That will be 2 volt, greater than 0.7. So they will be on. You get that?
Mhm.
Okay, in order to say on or off, you have to know VD. Okay? Greater than 0.7, they on. Less than 0.7, they off. The last one here. Okay? VD equal -3, -1. Okay, less than. So they will be off. You get that?
Yeah.
Okay, now, when you say the diode on, so you must be substitute diode by the battery. Positive here, negative here. Value will be 0.7. And that positive, that negative. Okay? Make sure you understand that. When you say diode on, then you have to erase the diode. We don't need that anymore. You substitute by the battery. Positive here, negative here. The value 0.7 volt. That is a key point. Make sure everyone know. Okay? And now we try to see working with field circuit. Okay, if I get this circuitry here, okay, on this circuitry, what V out equal?
.7.
That's a minute. Okay, what V out equal? 14 in order to do it. Okay. What you need to do. 14, you suppose the diode not here. What V out equal?
10 volt.
If not, diode. Okay, if the not a diode, then right at this point here, the voltage will be the same, 10 volt. So V out Is it that correct?
When the diode's not there, yes, it's 10 volts.
If they're not there.
Right.
Okay, now with the diode already in the circuitry, you know you get a 10 volt here. And that will be ground. Diode on or off.
Diode's on.
Correct? Diode off. Redraw the circuit.
And Mr. Pham, a question. The anode is got the 10 volt side and the ground is a 0. So the anode is more positive than the cathode. Is that correct?
Exactly. That means one side 10 volt, the other side 0.
Okay.
Okay, plus minus 10. And this positive. This negative. And that 0.7 volt. Okay. After I set the diode on, I redraw the circuitry. And you see, I substitute the diode by the battery. 0.7 volt for silicon. So the question is, what Vout equal?
Be out with the diode in the circuit, like the one, the circuit above is 0.7 volts.
Okay,
With the diode in the circuit.
okay. Vout will be measured from Vout here to the ground. If you get a meter, DMM, okay, positive, you connect here, and negative, connect to ground. Then Vout will be equal 0.7 volt. When you measure the voltage across the battery, you get that battery voltage. Exactly in your car, you get a car battery. If you're using a meter to measure between red and black, positive, negative, and you're supposed to get 12 volt, a little more, doesn't matter. Even that battery connect into the circuitry inside your car. However, what I'm saying again, when you measure the voltage across the battery, no matter what, you get that battery voltage. Okay, any question on this problem here?
Mr. Pham, just one question. On the AC1 lab volt, they,
No, I'm talking about AC now.
no, I'm not. I'm just asking, I'm talking
no.
about,
The thing is, I'm not going to the AC. Why you ask?
Mr. Pham, that's
AC?
not my question. That's not my question.
No. Question supposed to be regarding what we are doing.
That's what I'm asking.
No, I'm not talking about AC.
Neither am I. My question is the open circuit voltage right here. When you got an open circuit voltage, you're only measuring like only the battery. Is that correct?
No, only thing I said, when you measure the voltage across the battery, no matter what, you get that battery voltage.
Okay, thank you.
That's what I want. If you're looking into that one, VL mean across 0.7 volt battery. No matter what, you can get the battery 0.7. Okay, any question? Now, you can get the current flowing. How do I calculate the current I? That I using V in. Current I mean the current flow through R1. Same thing I can say I R1. Tell me the basic definition. You know the Ohm law. Ohm law I. V divide R. However, when you're using the Ohm law, you have to understand I, what is the current? V, what the voltage? Okay, so now if I apply into here, now I equal, sorry, that is wrong right here. Basically, V. Okay, what V equal? That have to be VR1. That means the voltage across here. By definition, what VR1 equal?
BE minus BE 0.
V in minus V out. That means the difference between here and here. Divide R1. And then I equal V in is 10. V out we already calculated. 1K. 9.3 volt. 1K. And that given you 9.3 milliamp. That is a very, very basic. You must know how to do the calculation. Okay, up to that point on this kind of problem. Any question?
It's okay.
The thing is, later, now on, I try to get away from much of calculation. Just require understanding. That's the key point. Okay? If no question. I go to another one. Okay. Good V out.
10 volts.
Diode on or off.
Diode off.
Off.
Okay. The reason they off, that means on this side you get a 10 volt. On the other side you get a ground. Okay, so you can see VD equal 0 minus 10 minus 10 volt. Less than. So that's why diode off. And now the diode off, then you can see the circuitry look like. Open.
And Mr. Pham, in your formula, VD equal 0 minus 10, the 0, is that the same as VA and the 10 is the VC?
A right here. C right here. Right?
Right. So the 0 is the A?
Yeah, they will be VA minus VC.
Okay.
VA round 10 volt.
Okay.
So less than 0.7.
Okay, thank you.
So now they open. Same thing. The question is what V out equal? What the current equal? The thing is when I asking your guy try to speed it up. Okay. The thing I want to get the feedback to see how many students can be following the lecture.
The V out should be 10 volts and there's no current.
Exactly. V out 10 volt. And that current equal 0. Current cannot flow in the open circuit.
And that's a reverse bias, right?
Yeah, same thing. On mean forward bias. Off mean reverse bias. Either way you can to say it. You say it on, okay? You say it off, you know what happened if it off. Okay, any more question? So that will be bring it up to you. In order to do solving the diode problem, you must know diode forward bias, that on or reverse bias, okay? Without know that, okay? then we cannot do anything. So this they park here. We already did done last time. Sideways. Relation, between the frequency, a period, okay, or V peak or V peak to peak. That's what we need to know. Okay, that one we already done. That one I just talking to you. And that will be first ideal. Okay, and second, approximation. Okay, either VD can be 0.7 or VD can be 0.3. Depend on material. They make the diode, silicon diode, 0.7 volt. Germanium, 0.3. Okay, and this problem here, we just go through for you. Okay, and this last time, we already solved that problem. You get any question about number 3 and number 4? Number 3, they say diode on or off, and we say diode off. Current I equals 0. Number 4, say diode on. Okay. We already get through that one. Oh, okay, now. That one also another one. Very, very important thing in electronics. Now you get another diode they call Zener. Zener diode. This is the symbol for the Zener diode. Okay. Zener diode, they can be working like they can be breakdown, or they just working like normal diode. Now, if I said I get the Zener diode with VG equal 10 volt. When you get the Zener, you must know what the Zener voltage. Like you want to buy a Zener diode, they will be asking you what VG you want. That means you can say 5 volt, 10 volt, 15 volt, no matter what, but they must get the voltage. Okay, now, if I say diode Zener working at a breakdown, then you're not using this symbol. You must substitute by this symbol with the positive here, negative on the other side, and the voltage will be 10 volt. That is the key point. When you say they break down, then you don't care about this symbol here. But now you have to convert it to the battery with this side positive with the side negative, and the value equal 10. Okay, and now if they say they working just normal diode, then the diode will be substituted by this battery here. Positive on this side, negative on the other side. The thing is when diode on, you must be remove diode, substitute by the battery. If you don't know how to draw that battery, you cannot solve the problem. A major application for Zener diode is the type of voltage regulator for providing stable reference voltage for in power supply, voltmeter, and other instrument. You understand most of the power supply, they must get the Zener. Guarantee they can get a certain voltage they want. Okay, now go to this problem here. For the circuit show, VG equal 10 volt. That's what they given right here. If the voltage V in 20 volt, the question is, what is V out? How can we solve this problem? No, let me know.
Since the 20-volt battery, the battery's at 20 volt and the Zener diode is rated at 10 volt. And the anode is negative. So it's in breakdown, I think.
Okay, now to solve this problem. First thing you have to know what V out equal without the Zener. No Zener.
20 volt.
The thing is that look like they open right here. No Zener. Then you get 20. That's the first thing you must do it. So now the Zener voltage is 10 volt. So any voltage higher than 10, then they break down. They break down mean they cut it down only equal 10 volt for the Zener. Okay, so that's why you can say Zener breakdown. Then V out. That's a Zener voltage. Any voltage higher than Zener, they cut it out. So the answer here will be equal 10 volt. And the next, the question is, what is the current I here? That means I R equal V in minus V out divide to R. That will be 20. 10 divide unit 20. Okay, up to this point. Any question?
Yeah, one question, Mr. Pham. If the source voltage or the input voltage is higher than the Zener voltage, does that tell you right away anything about the Zener, the output?
Yeah, if the voltage supply higher than Zener voltage, then they cut it out. You get a Zener voltage, no matter what.
Okay, so then you're saying if the input voltage is 20 and the Zener voltage is rated at 10, it could be rated at anything, but in this case, it's rated at 10. So then the output is 10.
Exactly.
Okay, thank you.
That's what they need a Zener. They need only 10 volt. However, sometimes V in can be 100 volt. They cut it down, only 10. Okay, any question on the first part right here?
Just a quick question.
Yeah, go ahead.
If the VN was 10 and the Zener is 10, would that mean that V out would be 0?
Okay, V in equal 10. Okay, and V out also equal 10 volt for Zener. Okay, so that means the difference will be 0 volt across the resistor. Okay, and no current flow.
Okay, thank you.
Yeah. Okay, now we go.
And Mr. Pham, one question, what that lady just asked. So she said if the VN is 10 and the Zener is 10, you get 0 across the resistor. But for the give breakdown, you would have the VN would have to be like 11, 12, or more than 10. Is that correct?
That only thing higher than 10, they break it down.
But if it's so, what happens to the circuit when it's like what she just said?
Okay, they said the same voltage. Then you still get 10.
Okay. All right.
The purpose is they want at this point must be 10, no matter what at the input if they higher.
Okay. Thank you.
You're welcome. Now, they said they can the voltage in 5 volt. Okay. What V out? First thing again, I want to emphasize, you must calculate the V out without Zener.
So V out would be 5 volts then.
Exactly. V out equal 5 volt.
And the Zener would not be in breakdown because 5 volts is less than 10 volts.
Exactly. So now That's what the first thing you must know. Write down the Zener, what voltage. You say 5 volt, that's correct. Okay, and the Zener is 10 volt. So they not break down.
It's the same with the -5 voltage? Or -5 volts?
Now we're talking about this one first, okay? Don't try to confuse. Zener.
But C says -5 volts. I just want to be clear that we're solving the problem with -5 volts.
If you say V in is negative, right?
Correct. Look, letter C says V in is -5 volts.
Okay, that just a minute. I'm talking about 5 volt right now. You get the V out equal 5 volt. And you say Zener not break down. Okay, now if it not break down, then what happened next? How the Zener working now?
Like a regular diode.
Okay, so Zener working like normal. Normal diode. Okay, normal diode, that means you can say they look like, right? Positive here, negative here. And one side 0 volt, one side 5 volt. Then diode is correct.
Correct.
They will be open. So V out will be Michael. That's what I try to bring it back up to back here. Just quick, I can clear this one. Okay, that's what I try to bring you guys back here, right here, like normal. This side positive, this side negative.
Oh, and the
Oh,
ground is 0. And then since, well,
what is the current?
Current 0.
Perfect. That VL will be equal 5 volt. And I will be 0 amp. And now the other student asking, okay, if the input here is minus 5 volt, see what happened. Okay, now you can tell me. First thing again, have to be supposed to be no diode. What voltage here? Correct?
Correct.
without the diode. Then you get -5. And now you get the diode. And the diode working normal. Okay? Just like normal diode. No breakdown. This is positive. This is negative. So VD equal 0 minus 5. Diode on, right?
Mhm.
Okay. When you set a diode on, I want to take out that substitute by the battery. Negative, positive, 5 volt, 0.7. So V out equal what voltage?
4.3.
I already telling you. You set the diode on. Forget this guy. You using that one. That one. Substitute by the
0.7. 0.7.
The thing I did is a negative. Positive here. So the VL will be minus 0.7. Okay, and the question up to that point. Let's say, go to the next one. For the circuit shown, shown for no load RL. That means now we don't have any load connected. This is the load here. They're not connected yet. So they want to know I L. That means the load current.
But you want us to find out VD first, right, Mr. Pham? Is that correct?
VG already given.
No, VD. In other words, you said, I thought you said to take the diode out and then see what you get.
Exactly.
So
That's
then,
the first thing you have to do.
so you'd get 24 then, right?
Exactly. I say no Zener.
Yeah, that's what I was talking about.
I keep go over and over. Okay. V out equal 24 volt. Okay. If it's still not clear for you guys, just let me know. If you cannot understand this thing here, you can get a lot of problem later on. First thing, without the Zener, and also no RL, load, then I know we are 24. Okay, so with the Zener, V out equal without Zener 24. Now, if you get a Zener, what V out?
12.
Twenty-four minus 12.
12 volt, right? Zener breakdown. Then V out equal VG.
Hey, Mr. Fan, is it 24 minus 12? But like that gentleman said, or how did,
That doesn't matter. But they higher than 12. Then they will be equal 12.
okay, all right.
Equal the VG. We're not doing calculation anymore.
Okay.
Okay, so what IL equal? That means no load, okay? Then the current.
So
goes
the
to
24
load.
minus 12 divided by, well, forget it.
Right? No load, that means they open right here. Open right here. So that's why no current can be flowing. That's what they're talking about. No load. And the next,
So the IZ then is 24 minus 12 divided by 470.
exactly. Okay, so number B, IG equal 24 minus 12 divide 470. Okay, that means the current flow this one. They're not going out. Can you open? Okay. So basically, you get IG and V out. Answer will be 12 volt. Okay, number D. Now they say they want IL with the load. How do we calculate it? What IL equal?
Well, voltage is the same on both sides. It's going to be 12. So 12 volts divided by 490.
Perfect. That means V out divide IL. Okay, that means you get 12 volt divide to 490. Okay, and C, D, E. They want current, Zener. How can we calculate the Zener current? You can say this is the total current. Go to Zener, IG, go to load, IL. So easy to recognize.
IT minus
I
IL.
IZ minus IL,
I total
I total,
minus IL,
I total.
right?
Mhm.
And I total equal 24 minus 12 divide 470. Okay, so you get the I total, you get the IL already. Then you're able to calculate IG. Either you want to be technician engineering. This is a very, very basic to working with the diode or Zener diode. Any question up to this point?
Hey, Mr. Pham, up top in the left corner where you got the I total circle, the current goes through that resistor. So then you got the IZ circle. So the I total and the IZ are the same, right?
No. I total not the same with IG. They will be the same without the load.
Oh yeah, that's the one without the load.
Okay. Now.
The hard part.
Now you get AC. Okay, before we go to that one, I will be asking you a few things. At certain point, okay, you get 2 voltage. AC and DC. I given you example. DC equal 5 volt. AC equal 50 millivolt peak to peak. How they display? On oscilloscope. Okay, so basically you can get this is oscilloscope. That will be time. That will be amplitude volt. 0 here. Now,
What is the D equal 5?
okay, so basically DC, okay?
Oh, okay.
That they display DC, 5 volt. Okay. Now, what happened for the 50 millivolt peak-to-peak sideways? How they can be displayed?
It's 25 millis each way, positive and negative.
On which one?
For AC, it's going to be 25 milliamp or millivolts positive, 25 millivolts negative.
That's what you're talking about, that one, right?
No, around the x-axis,
Around 0,
around 0 x-axis.
that's wrong.
So the 25, if you take the 50 millivolts peak to peak and divide it, it'll be 25 millivolts peak times 0.707, and that'll make it similar to like 5 volts.
Now, what I'm asking you, at a certain point, you get two different type voltage, one 5 volt and 150 millivolt peak to peak. When you show up on the oscilloscope, how they look like? They will be displayed like I draw for you.
AC riding on DC or something.
Right, the 50 millivolt. So you can get 25 on the top, another 25 in the bottom here. This will be in the middle. You don't know, now you have to know.
AC riding on DC.
Right. Okay, now, if they asking you measure the peak to peak, how? How can you measure? Who knows? You should know in order you can do the left. Okay, now I can tell you. If they display this way, you cannot measure the peak to peak. Can you tell me why? Okay, I can draw this one for you again. Okay, 5 volt right here. And
5
this
volts.
signal will be look like. You cannot see the sideway. How can you measure the peak to peak? The thing is the 5 volt is too big. And the voltage peak to peak is too small. So when you display on the oscilloscope, you can see the sideway, but you cannot measure. The thing is they too small.
So are you saying we need to have the DC equivalent of the AC, which would be like a RMS value or something?
No, nothing to talking about IMS. Right now I'm talking about, you tell me how can you measure the peak to peak? So basically the peak to peak you can measure from on the top, right?
Right,
To the bottom.
right.
However, like this one, you cannot see it. How can you measure? The thing it look like the sideway burying into the 5 volt. You guys already learning left volt for few semester. Can you answer for me? How do we measure that sideway?
Well, you measure sideways with an oscilloscope, right?
Right, that's what I said. They display on the oscilloscope with both signal, 5 volt DC and 50 millivolt RM sideway. The
You
thing
gotta
is
do
the
it.
5 volt is too big and the AC too small. You cannot see that sideway. How can you measure?
You have to use some type of reference point.
Nobody knows. Maybe almost time to quit.
No, not yet, Mr. Pham. We want you to tell us.
Okay, now, when you're working with the oscilloscope, you get DC coupling. AC
Oh,
coupling. Okay, now, you will be set the oscilloscope either DC coupling or AC coupling. My question is, what happens if you set it to DC coupling?
You can see the DC and the AC.
Exactly. You
And
can
if you set
see
it to AC coupling, you'll only be able to see only the AC.
exactly. When you say you set DC coupling, they display both AC and DC. So
When you
now,
set it to DC coupling,
yeah, then now you want to measure the AC, you have to remove the DC. So you must set your coupling to AC. So that will be bring this down. This is the sideway here. Now you can measure. No more 5 volt. Okay,
and then we'll be able to see the 50 millivolts peak to peak, right?
yeah, you can see the big signal. The thing is now only AC. You see, they can start from 0. And you can make it bigger. No big deal. That is a very, very important thing for the technician.
So, Mr.
Okay.
Pham, let me ask you a question. So
Yeah.
basically what you want us to know is we need to know when to put the oscilloscope on DC coupling and when to put it on AC coupling. Because it seemed like you just asked them a question here with respect to the 5 volts DC and the 50 millivolts peak to peak AC. So we need to know which one to put the scope on depending on what you're asking.
Exactly.
Okay.
If I want to measure sideway, peak to peak, and that also include DC voltage, you must set your oscilloscope to AC coupling.
To see the AC signal.
Yeah, you only see the AC sideway only.
But if we set it to DC coupling, we would be looking at both the straight line for the 5 volt DC and barely be able to see the AC signal.
Right, you cannot see AC.
All right.
You can see, but you cannot measure. They choose
Oh,
you.
okay, all right.
When you start with working with the transistor, and you can see at a certain point, you can get 2 volt DC, and the AC only 10 millivolt. If you want to measure the AC, you don't know how to use in your scope. No way. To measure the AC, you must set your scope to AC coupling. Okay? When I will be teach your guy also on the MSIM 7. Okay? To simulate the circuitry, and I will be helping you. How do we measure that AC signal? If you know how to do on the MSIM 7 simulation, that will be exactly what you will be doing with your real scope. The thing is, I'm still working on, okay? I try to set it up the left volt. So I will be helping you guys to solving the problem when you do the left volt. I'm not going to left by just follow instruction and try to set it up, measure. I don't care. What I really care is when you apply input, you measure the output, they not correct. What can we do? And I will be teach you step by step in order to solve the problem. That's what we call troubleshooting. Okay? That is really you need to learn. In the lab, we not try to let you build anything. Like, sometimes in the city college, the thing that they don't have a tool like we do. That means the left volt. The left volt is very, very good to teaching for the technician. You don't have to build the circuitry, but you have to build the way the lab wants you to build by connect the pole, the jumper. That is built, okay? But the key point is, after you build, you apply input, you measure output, you not get correct value. Then you have to know what to do. That's what I want to teach. Okay, any question? Anything else? If it's not, okay, then have a good weekend.
Thank you,
We'll see
Mr. Pham. Thank you.
on Monday.
Thank you, Mr. Pham.
All right, now, thank you.
Yeah, you are
Thank
welcome.
Have a
you.
great
Good
weekend.
night.
Good
Good
night.
night. Good night.